This is my video assignment number 3, labeling the ketone A and the aldehyde B. It's just added to a base and it's added slowly with heat, and that's the final product. So I have the mechanism here. We have the hydroxide goes and takes the H from the alpha carbon of this ketone, which results in the electrons being donated to the alpha carbon, which then acts as the nucleophile and is attracted to the carbon of the carbonyl on the added aldehyde, and it kicks off the electrons to the oxygen and creates a negative charge and creates a bond between the alpha carbon and the carbon of the carbonyl on the aldehyde, which then, now that we have water in the system, the negative charge from the water, or from the bonded product, is attracted to the hydrogen on water, and it goes and gets one, and it kicks the electrons off to the O, and then we have hydroxide again, which then goes back to the alpha carbon and takes another H and kicks the electrons back onto that carbon, which then transfers the creates a double bond between the two here, which forces the hydroxide to be kicked off, and then we have the final product and H2O. And for part 2, the reason that the second product must be added slowly is to prevent the aldol self reaction, because this is a ketone that is an aldehyde which is added, which would want to do the self process has more of an affinity to do that. And for the third part, these are the 3 remaining products that we have. We have the self reaction with the ketone acting as both the enolate and the electrophile, and they add together. This one's with the aldehyde self reaction. This would be the product that would happen more likely if the product were to be added quickly. And then this would be the other cross, which would be adding aldehyde acting as the enolate, and A acting as the ketone acting as the electrophile. And that's all the products.